So this video is going to be a walkthrough of the RPX 2.0 and why it's different and what the purpose of the switch is. There's already an installation or a hookup video on V2.0 on the products page for the RPX. If you scroll down maybe halfway or 2/3 down, you'll see the setup video on how to hook it all. Most important thing is to always make sure this Field Tech barrel jack here is plugged into the USB port here. If you accidentally take the barrel jack cable and hook it from the Field Tech to this port on the battery, that's 12 volts and you're going to fry this unit. So only power this by the USB port, which is 5 volts, and the RPX by the 12 volt barrel jack. So the first thing I'm going to do is I'm just going to turn this on, the RPX. The pump wave switch is off, and it's going to be powered by 12 volts. I do not have the audio input connected so that you can see just the default mode for the RPX. So what you see here is this spectrum analyzer is set for a frequency of 3.1 megahertz, 3.1 and then all zeros. And what we see on the scope here is that we have the 3.1 megahertz fundamental, and if I zoom in on this, you can see that it's essentially a square wave. These programmable oscillators can't really make a perfect square wave at those frequencies, but the frequency is more important than the perfection of how the waveform actually looks. And so what we see here is that the scope is showing 3.10001, and then it goes back and forth between 0. So it's accurate out to 1, 2, 3, 4, 5 decimals. So this is the 3.1 megahertz fundamental frequency, which the audio frequencies need to be mixed with in order to create the proper create the right frequencies in a proper way. And this is the only proper way to do it, whether you have a plasma tube higher power unit or you have an electrode delivery unit. Most of the electrode delivery units are nothing more than a signal generator outputting the frequency that is directly punched in, but that has absolutely nothing to do with Rife. That is not what Rife did, and those are all scams. This is the proper way to do it, which I'm going to show you right here. So what we have right now is the 3.1 megahertz fundamental, and you can see the waveform here. And what I'm going to do, and I'm still not hooking up the audio, but what I want to show you is what the pump wave is. And on the side of the RPX, a new feature is that there's a separate power light that comes on when the battery is hooked up, which is different from the light on the output here. And if the switch is off, you can still get the output, you just don't have the pump wave, and I'm going to go through that. So as soon as you turn the pump wave on, then you have the output light blinking. And so what we see is that we have this kind of bobbing up and down here, and this is zoomed out to the 3.1 megahertz fundamental. But what I'm going to do is I'm going to zoom out little by little by little, and what you're going to see is that it takes on the shape of a low frequency square wave like this. Now what we have here is this low frequency square wave, which is carrying the high frequency in this low frequency envelope, I guess you could say. It's basically superimposed on this square wave, and the reason is because this low frequency square wave is what gets it to penetrate and get past the skin effect, which is the downfall of all the phony Rife machines out there that are only using signal generators. Okay, so the square wave here gets past that, because this is showing that this is about 8.39 hertz. Hertz really applies only to AC, so we really should be saying 8.39 cycles per second square wave. And this is the genius of John Bedini and how he gets past the skin effect. Okay, so if I turn this pump wave off, what you're going to see is that we just have the high frequency without the pump wave. Now the purpose of the pump wave is for electrode delivery to get past the skin effect, but if you want to take the output and you're researching and you want to send it to a pancake coil or any other kind of electromagnetic coil, or you want to use this to modulate some output of a plasma tube or whatever you want to do, you don't really need that pump wave because you're not using electrodes. So it gives you a little bit more versatility. These are, this set is going to be kept at the exact same price whether you buy the RPX by itself or the full combo kit. It didn't really cost me that much to upgrade a couple LEDs and a switch. There's a bunch of setup costs, but that's okay. So you get all that for the same price. Now this doesn't obsolete the original unit, and the reason it doesn't is because the original unit always only has the pump wave activated. There's no option to turn it off, and it's meant for electrode delivery, and that's where it shines as being a low power unit. Is a low power unit with electrode output, but it only works with the pump wave. So this might be more for you techie people who want to explore all options, and so there we have the 2.0. So what I'm going to do now is I'm going to turn the pump wave off, and I'm going to turn the signal generator on, and as soon as the signal generator boots up, I'm going to turn this channel 2 off, select channel 1. You don't have to do that. All you have to do is really just hit this sweep button. So if you hit this sweep button, it's already pre-programmed to sweep from 100 Hertz to 150 kilohertz. And that's quite a wide range, which will go quite a bit below the Rife frequency range, and then quite a bit above to account for things that Rife didn't know about. Now this is not making any claims. This is just a test device that creates the Rife frequencies the way that Rife did, for the purposes of studying how he did that. And I'll go through some examples of punching in some of these Rife frequencies, and you can see the spectrum analyzer is going to track it, and it automatically will hit them all without even having to program in any particular frequency. And that's the beauty of the sweep method, which was developed by Rife and more from his assistant named Hoyland. And so what I'm going to do is I'm going to connect the audio. Actually, I'm going to push this dial, and it's going to start sweeping from 100 Hertz to 150 kilohertz, sine wave, 50-50 duty cycle, no offset, and the output is set at 2.2 volts or 2.1 volts. You don't want to exceed that because you will fry the signal amplifier in here. It's a little miniature Class A audio amplifier that will take the signal from here and will automatically amplify it. So limit it to 2.1 volts. These are already pre-programmed, so you just turn it on, hook it up, hit the sweep button right here, and that's all you need to know. If this is actually a very versatile signal generator, there's a link. You can find Fieldtech FY2300 PDF manual online if you want to explore the other functions and do different different audio frequencies that you want to inject into the RPX. Make sure it's sine wave and limited at 2.0, 50-50 duty cycle, no offset, and this is set for 10 seconds, so it does the full sweep in 10 seconds. You can reduce the sweep so it hits everything more frequent, or you can slow it down to 10 seconds, maybe even 20 seconds or 30 seconds, whatever you want, so it stays on a frequency longer as it's sweeping through that range. So, or you can narrow the range of the beginning and ending frequency that you want it to sweep at. And these are frequencies that are going to be like audio frequencies. You don't directly punch in the end result because when you add the audio frequency with the 3.1 megahertz fundamental, you create what are called sidebands, which are the addition of the frequencies and the subtraction of the frequencies. And that is how Rife made the frequencies. And so what we're going to do is, this is set for 3.1 megahertz, and the span is, we're looking at an 800 kilohertz range. Okay, so what I'm going to do is I'm going to connect, now the pump wave is off, I'm going to connect the audio output, and instantly you're going to see these sidebands created, which we maintain the 3.1 megahertz fundamental, and all these little peaks that are rippling off are the audio frequencies in here that it's sweeping. Of course, this goes above the audio range, above 40-45 kilohertz, all the way up to 150. But nevertheless, these are the low frequencies coming out, and you add them to the 3.1 megahertz and you subtract them, and that's why you have these sidebands coming off on both sides. On the lower range and the upper range. Now what you see here is that we don't have the zigzag or the square wave. This is just a 3.1 megahertz with the sidebands, very, very pure. So if you want to put it to a pancake coil or other type of non-electrode contact output where you're not worried about the skin effect, then you can use this option here by leaving the pump wave off. So again, if I zoom into this now, you can see that there's a little bit of jiggle here. That's because there's the sidebands going on. So not only is it trying to measure 3.1 megahertz, it's trying to measure all these other frequencies that are created, which are the addition and subtraction. And that's why it doesn't look too clean here. But this is exactly what you're supposed to see. Okay, so what I'm going to do is I'm going to zoom back out, and we have the pure 3.1 megahertz with the sidebands. And these are automatically hitting the Rife frequencies, which I will show you. But what I'm going to do now is I'm going to turn the pump wave on, and that would be the application for electrode delivery to get past the skin effect using that low frequency square wave as a carrier. And so what I'm going to do is turn on the pump wave, and you see that this starts bobbing up and down. And again, if I zoom out, what you're going to see is this square wave with the high frequency fundamental and sidebands superimposed on that square wave, and this gets past the skin effect, and that's why the RPX is the only legitimate electrode delivery Rife machine in the world, indisputably. If they don't have this feature, which they won't, because this is John Bedini's method that he developed many years ago and applied it to various frequency microcurrent type of output devices, and nobody else has done that. Everybody is selling these all by themselves or other devices that you just punch in the frequency, and those are all fake. This is the real way how to do it with electrode delivery to get past that. This is the only legitimate one. So you can see the pump wave gives you this. I can turn it off, and then we get that. Okay, so what we have here, I'm going to show that we're going to be able to track the Rife frequencies, and we already know that the center is 3.1 megahertz fundamental, and so what we have on the sheet here, we have a column which is frequency in hertz. These frequencies are the actual Rife frequencies that corresponded to whatever he was claiming. The HN frequency column is a heterodyne frequency column, which means that's the frequency which is the result of mixing the low frequency audio with the fundamental, and you get the addition and subtraction of those frequencies, and those frequencies are going to be harmonics of these Rife frequencies. This particular Rife frequency of 191,803, if you multiply that 16 times, that equals a heterodyne frequency of 3.068848 megahertz. And what that means is if these sidebands are hitting 3.068848 megahertz, then that means it is a harmonic of the actual Rife frequency, and as it sweeps, it's going to hit every single frequency, and it will automatically hit every single Rife frequency without knowing what that frequency is, meaning you don't even have to know what that frequency is. It's automatically going to hit all of them anyway. So what we have is in the center is the fundamental, and these sidebands, there's a lower and the upper side, and there's the first sideband, second, and third. The closer it is to the fundamental, the more powerful it is. And the reason Bedini used 3.1 megahertz is because the heterodyne frequencies that are in the upper and lower sidebands from the fundamental are closer to the fundamental than any of the other fundamentals. Meaning Rife used a wide range of frequencies in the 3 megahertz range, from the low to the high 3 megahertz range as his fundamental, and Bedini is sticking to 3.1 because you're getting more amplitude on those sidebands for the heterodyne frequency that corresponds to a harmonic of the Rife frequencies. Okay, so what I'm going to do is I'm going to come back here to this. I'm not going to show the keypad over here. You'll see that I'm typing in the frequencies here. I'm going to get this little marker table down here so we can record the frequencies that we're scanning for, or tracking and marking. Okay, so if we go back to marker number 1, it's set for 3.1 megahertz. You can see that marker is right in the middle there. So what I'm going to do is I'm going to select 4 different heterodyne frequencies that correspond to a harmonic of Rife frequencies, multiples of the Rife frequencies. Okay, so I'm going to do 1.607450 is a Rife frequency, and the heterodyne is 3.2149 megahertz. So I'm going to hit 3.2149 megahertz. And you can see that it is twice the frequency of the Rife frequency. And every time it goes down and it comes up on top of one of the peaks, every time it hits a peak, it's at the peak amplitude for that sideband, second sideband, then first sideband, very close to the fundamental, which means it's hitting that particular Rife frequency pretty hard with a lot of strength. Even when it's not on a peak, that frequency is still being hit, just not at the peak. So it's still effective on getting that frequency. So I'm going to pick another one. That's kind of a high one. Let me get the lowest possible one. Okay, 191,803 hertz. That corresponds to 3.068848 megahertz, which is 16 times that frequency. So if I go to marker number 2 and I type in 3.068, 3.068, 848, oh, excuse me there, 3.068, 848 megahertz. Now marker number 2 corresponds to that heterodyne frequency, which means it's hitting a harmonic of the Rife frequency of 191,803. So we can see that number 2, although it's not hitting on top of a peak, well, it did that first sideband just for a moment, but it's still up here, so it's still hitting that frequency. Okay, let me pick another random one. Let's see, 2.876. Let's go to marker number 3. Let's see, 2.8766 megahertz. And you can see that 2.8766 megahertz is 4 times the frequency of 719,150. Which is supposed to correspond to whatever. Okay, so that number 3, you can see that it's hitting these peaks, hitting that peak, 4th, 3rd peak, hitting the 2nd sideband peak. Okay, and the reason it resets is because it's going from 100 hertz to 150,000 kilohertz. Rife went from 0 up to about 40-45 kilohertz, which is what an old analog audio oscillator is going to do, because that's the audio range, and above about 45,000 hertz, that's not really considered the audio range anymore. And again, Bedini is sweeping from 100 hertz to 150 kilohertz to go, that's 90 kilohertz above audio, but that's to hit the frequencies that correspond to stuff that Rife never knew about. And that's kind of the idea behind it. So you can see that these frequencies in here for number trace 1, 2, and 3 are all being hit. Now let me select one more. Let's see, 3.076. Let's go to marker number 4. 3.076. That's it, megahertz. Okay, so the 4th marker right there is right close to the fundamental. And you know it's right next to the peak because 3.076 is obviously very close to 3.1 megahertz. And so it's right there close to the peak. It's getting pretty good amplitude right there on those particular frequencies. So just because you don't see it riding on these different sidebands and hitting the peaks, that doesn't mean it's not doing what it's supposed to do. This is showing that it's doing exactly what it's supposed to do. So let's see, I'm going to go to frequency number 1. Let's see, now let me go frequency number 2 that I'm tracking, and let me put in another frequency, something like 3.029 megahertz. 3.029 megahertz. So number 2, 3.029 megahertz is 13 times 233,000 hertz, which is a Rife frequency, and you can see that number 2 was peaking on the first sideband right there. It's peaking on the first one, second one, the first one. Well, actually, it was the first and then the first again. So it's getting pretty good amplitude there. But you can see that without knowing what the Rife frequency is, as long as you sweep and you mix it with the correct fundamental, that you're automatically going to hit all the Rife frequencies. And if anything out there is called a Rife machine and it's not using this sweep method like this, it's completely phony. It's fake because there's purposes to doing this with the sideband method. Also, Rife did not actually understand what all his own frequencies were. Hoyland understood the method and developed the sweep method, where he was actually hiding all these Rife frequencies inside of the heterodyne frequencies as harmonics of the Rife frequency. And so this is the way that he can take an audio generator with a fundamental frequency, bring them together, and then automatically hit all these frequencies. Because this is very, very hard to dial in these frequencies exact. So as long as you just sweep through over and over and over with an audio generator and the fundamental, you automatically have it. And that was pretty much the ultimate evolution of Rife's technology that almost nobody's manufacturing except myself and one other person. But the genius of this device is that this is only a couple watts at max, but with electrode delivery and the pump wave, it gets past the requirement of having high power. And that's why this is so brilliant, and this can be manufactured and got out as a test device that people can examine on their own to see that this really is doing what it's saying that it's supposed to do, which is create the Rife frequencies accurately. So anyway, hopefully that's helpful to you. That's kind of a walkthrough on the system, why the pump wave is there, why you can turn it off and on, and how to produce the frequencies. So there you go. This is the real Rife frequency generating method. So beware of signal generators all by themselves claiming to be Rife machines. You cannot just pump in the frequency and expect it to do it, because you need a wobble. You need a wobble in a frequency to be effective. And if it doesn't have the pump wave, these high frequencies will just trickle over the surface of skin or whatever and will not penetrate. So that's the RPX 2.0. You can go to vril.io, which is vril.io, mouse over products, and you'll see the RPX page. Also, make sure to check out the Lukovsky MWO that we manufacture, and also the Tesla one-wire experimental system. Thanks for watching.